Hello and welcome. In this video, we are doing the November exam 2017 IEB question 8. As always, I advise you attempt the question by yourself and then come back to watch the rest of the video after that. So what we have here is a series. We've got x plus 3, next term is x minus 3, and the next term is 12 minus x. And we are told that this is apparently convergent. So it's convergent geometric series. So the key word there is basically convergent, right? And the fact that it's a geometric series. And they say we need to show that x cannot be negative 3 over 2. Well, that's a very unusual question. Typically, you're never asked to show that a variable cannot be a certain number. Typically, you are showing that x is equal to something. But here you're being asked to show it's not equal to that thing. So, well, the best way to approach something like that is to assume that it is equal to that and see what sort of trouble do you run into. So it is to assume that you have your x as negative 3 over 2. So assume that it is, and then see what sort of trouble do you run into. So if it is that, then you're going to replace x by negative 3 over 2 on the first term. All right, that's the first term from there. Okay, and then let's add the next one, which is again we replace x by negative 3 over 2. There's a minus 3, and let's keep going with this. Mixing up my colors there. So let's keep going with this. We do the next one, which is going to be 12 minus. So this is going to be 12 minus the negative 3 over 2. Okay, so, and I find out what these numbers are. So these numbers are basically 3 over 2 plus, let me be consistent with my colors here. So 3 over 2 is the first term. The next one would be, if you combine that, that would be negative 9 over 2. And the next one is, if you do put that together, you'll get that that's the same as 27 over 2. So then, because you have this, you now can do the ratio, which you can just take this term divided by the previous one. So you could just take negative 9 over 2 divided by 3 over 2 to get what r is, and that is an r of negative 3. But this is problematic because this does not is not between negative 1 and 1. Therefore, r is not between it's not between negative 1 and 1, right? And that's what you need for, that's what you need. Therefore the series is not convergent. All right, is not convergent. And this is a problem because at the start there, at the very top, it said this was a convergent geometric series. So if r is allowed to be that, I mean, so if x is allowed to be that number, then we will run into this problem. So x is not, it cannot, should not be allowed to be negative 3 over 2 because it won't work. So we know it won't work. So we just proved that if we allowed it to be that, then our r will suddenly not be between negative 1 and 1, and that will violate our condition that this was meant to be a geometric a convergent geometric series. So yeah, so that took a little bit of an explanation there for A1, but A2 shouldn't take too long. I think we should run through that quickly. So we proved that. So I'm going to erase everything just to create space again here. So we proved that. Now let's do 2. So determine the value of x. And that should be, again, kind of really straightforward. Now to find value of x is all about taking the second term over there, divided by the first one, and knowing that that's the same as taking the third term divided by the second one. Um, and that should be the algebra that you can solve by simply cross multiplying in this situation, allowing you to have x minus 3 squared equals to x plus 3 multiplied by 12 minus x. From here, I'm not going to do their FOIL and all that special types of algebra, so you guys would have to do there to finally end up with these two answers, which you would get after you've done everything else. But you would recognize that this cannot work because we've already proved that that one is problematic. So basically, now we can sort of learn now that this first question was preempting what we're going to see when we go to question 2. So we do realize question 2 gives us two x values, one of them being negative 3/2, and we already know that that one doesn't work because we just proved it in the first question. Okay, so we must have at least that one working for sure. So we know that that's the one, and yeah, so that's how you would do that. Question 2, really, really straightforward there. I think let's go to B. Now, B has nothing to do with A. As you see, there is no relationship between these two questions, and the reason we see that is there was no question heading where you'd have a question that is sort of continuing with A, B, C, D. So A is sort of done with 2, and now B is a new question, basically. And so what we're learning from B is we have a geometric series. Again, that's a different now, obviously, geometric series, but we're given a geometric series here. And it's important to just keep it in mind that this is geometric. And we are given that S4 is equal to that, S5 is that, and S6 is that. Okay, and the requirement is that we need to determine, um, uh, in terms of n, the sum to n terms. All right, the sum to n terms of the series. So we know the sum to n terms in general is like this of a geometric. Obviously, I'm careful to remember that. So this is what it's like, all right? This is, in general, I know sum to n terms is this. But this as is, it's in terms, this is now in terms of A, R, and N, basically. So the actual formula is in terms of A, R, and N. But the question is only looking for in terms of N. So the question is happy for you to find A and R, but you don't have to find N. So you can leave the entire thing in terms of N, but you should find A and R because it doesn't want anything in terms of A and R. It wants just in terms of N. So that means our task is basically to find A and R for this geometric series using obviously the given information over there. Now, what we notice about the given information there is that these is S4, S5, S6. These are consecutive. They're coming right after the other. So this is great because this must be able to remind us about the fact that if we ever needed t of some n, T of n, then we can just say Sn minus Sn minus 1. Basically, if you've got some the S of 5, then and S of 4, which we do have in this case, then you could say T5 is the same thing as S5 minus S4. This is kind of what we're learning from that red formula. And we can then just substitute in this case. That S5 is 15 and a half minus 7 and a half, and that's clearly 8. Okay, so we get that, and we can do the same thing with S6 because we have S6 there. It's 31 and a half if you look at the top of the screen. So we can go T6 using the very same red formula. T6 is the same thing as S6 minus S5. And this is 31 and a half minus 15 and a half. And that's obviously 16. So this gives you term 5 and term 6. That's great to have. So you have in a sequence where you've got T1. I don't actually need to write this at all, but I'm just going to write it anyway. You've got this in your sequence, T5, T6, T7. Well, I can keep going, but what I just want to emphasize is that now I know that this is 8 and this is 16. I don't know anything else, but at least I know that after using the given information, I was able to get that. And from this, I can find R just by going T6 divided by T5, which would be 16 divided by 8, which is 2. So I now found R, and I'm going to use it when I come back here so that I can replace it here and there, and I've got one less variable that I don't want eliminated. So now I'm going to, not eliminated, but substituted by its value. And then I need to find A as well. A would have been nice if I knew T1, but I don't know T1. So I need to find A using another strategy here. One strategy I'm thinking about is I know for sure T5 in an arithmetic series is just AR to the power 4. And that's important information because I can just say this means to me, this just means that AR to the power 4 is equal to 8. But wait a minute, I already know R. I mean, R is 2. I just found that just now. I just found that. So I can easily use that to say, obviously, 2 to the power 4 is 16. This means 16A is equal to 8, allowing me to say A is equal to a half. Now I have A and R. Coming back here, now this equation is now going to be in terms of just n, because I know A, I know R. I'm going to be changing all of those and put the numbers that they are, and I will have Sn just in terms of n. Okay, so I would be able to do that, and I'm going to write that down now. So Sn, finally, I know instead of A, it's a half. I know A is a half, and I've got R, which is 2 to the power n minus 1. I don't even think I needed those brackets in there. I don't even think I needed these brackets here, but it's fine. I'll let them stay there. And I've got 2 minus 1 because R is 2. And I can simplify that quickly. This is just Sn is the same thing as a half bracket 2 to the power n minus 1. Okay. And that is the expression for Sn in terms of n. So that's what I learned from this. Obviously, this is nice for if you obviously need any sum to any number of terms, you can do it easily just by replacing whatever sum you're looking for. So if you want a sum to the first 100 terms, you would just go ahead and, do this. Not to say that the question actually asked for this at all. And the question is over there, but I'm just saying that if you ever needed s of the first 100 terms, you could do it using this expression. And if you needed 200, you just replace the 100 and put 200. If you needed 144, you just do, you kind of get the point. So that's the expression in terms of n, and you can just replace n as you wish depending on what you're looking for. So this is not a specific sum of the first specific number. It's just sum of the first n terms, and n is intentionally not specified. Okay, so we've done this. I think I don't even know how long this video is as I'm in it right now, but it does feel like it was a long video, and I do apologize for it. I will try to stick to one question per video next time. But thanks for watching. If you are listening to this at this point, thanks for watching to the very end, and yeah, all the best and keep learning.